Every single morning, in every city in America, one of the most mechanically violent machines ever built rolls through your neighborhood at 5 miles an hour, and nobody looks twice. That's the trick. The garbage truck is so ordinary, so expected, so background, that the extraordinary engineering happening inside it is completely invisible, and what's happening inside it is genuinely hard to believe. By the time that truck reaches the end of your street, it has already generated forces comparable to an industrial steel baler. It has lifted, swallowed, and compressed hundreds of pounds of waste into something closer to concrete than garbage. And it has done all of that quietly, efficiently, and without a single person on the crew climbing inside. This is what actually happens inside a garbage truck. Before the first bin is touched, the truck is already alive. The diesel engine is running, and hydraulic fluid is circulating through lines pressurized to around 2,500 pounds per square inch. That pressure is stored, waiting. The packer blade inside the drum sits at the rear of the body, ready to cycle. The hopper, that wide steel trough at the back where everything gets thrown in, is open and empty. The hydraulic system is the heart of this machine. It powers everything: the lifting arms, the packer blade, the ejection ram. Without hydraulics, a garbage truck is just a very heavy, very loud box on wheels. With them, it becomes something closer to a mechanical predator. Now, the route begins. The crew pulls up to the first stop. On most modern residential trucks, a single operator handles everything from the cab: a joystick, a camera feed. A robotic arm extends from the side of the truck, grabs the bin, lifts it over the hopper, and tips it upside down in a motion that takes about 7 seconds, start to finish. 7 seconds. Then the arm sets the bin back down, and the truck moves on. What just happened in those 7 seconds is where it gets interesting. The waste drops into the hopper. Loose bags, broken glass, cardboard, food waste, all of it tumbling down into that steel trough. At this point, the garbage looks exactly like you would expect. Chaotic, unorganized, taking up enormous space. Then the packer blade activates. The packer blade is a curved steel panel, roughly the width of the truck body, and it does something that looks almost simple until you understand the forces involved. It sweeps down and forward in a single arc, pushing everything in the hopper through a small opening called the packer throat and into the main drum of the truck. But it is not just pushing, it is compressing. As the blade moves forward, the garbage has nowhere to go. The drum is sealed in front. The throat opening is small. The hydraulic cylinder driving that blade pushes with a force that can reach 80,000 pounds on heavy-duty units. That is roughly the total weight of a fully loaded cement mixer rolling down the highway. All of that force concentrated through a gap the size of a large television screen. Cardboard boxes that were 2 feet tall become a couple of inches thick. Plastic bottles collapse completely. Garbage bags that were round and full are flattened like they were never inflated at all. Steel cans, milk jugs, yard waste. It all gets compressed into a dense, layered wall of compacted material that slowly builds from the front of the drum backward. Now here is the part that breaks most people's intuition. You would assume a garbage truck fills up from the back. The stuff goes in at the rear, piles up toward the front, and eventually, the drum is full. Logical. Completely wrong. The packer blade doesn't just push waste backward into the drum. It actively drives the entire compacted mass forward. Every cycle of the blade pushes the previous load further toward the front of the truck. The waste is constantly being relocated, not stacked. Think about what that means. The first bag thrown in at 6 in the morning, 5 miles back, is now pressed against the very front wall of the drum. 50, 60, 70 pickup stops later, it has traveled the entire length of the truck body without the truck going anywhere. The machine is, in a very real sense, eating itself from the inside out, continuously digesting and relocating its own contents to make room for more. This is why a standard rear-loader garbage truck, which looks from the outside like it might carry 10 or 12 tons at most, can actually carry up to 15 tons of compacted waste on a single run. 15 tons. That's the equivalent of taking every piece of furniture, every appliance, and every belonging out of roughly 40 American homes and compressing all of it into the space of a single moving truck. And it does that in a single morning shift. By mid-morning, the drum is approaching capacity. The packer blade cycles are getting shorter. The compacted mass near the front wall is dense enough that it barely moves with each new load. The hydraulic system is working harder. Pressure readings in the cab are climbing. And something else is happening that nobody outside the industry ever thinks about. Something that starts the moment the first bag of food waste gets compacted and gets worse with every single stop after that. The truck is slowly filling up with one of the most corrosive liquids on Earth. When organic matter, rotting food, wet cardboard, and decomposing yard waste get crushed under tens of thousands of pounds of pressure, it releases liquid. A dark, foul-smelling, chemically complex fluid that the industry calls leachate. It seeps out of every compressed layer. It pools at the lowest points of the drum. It works its way into every seam and groove inside the body of the truck. Leachate is not just unpleasant. It is genuinely aggressive to metal. Left unchecked, it would eat through the floor of the drum in a matter of years. It corrodes welds. It attacks seals. It finds the smallest gap in a drainage fitting and widens it, slowly, relentlessly. This is why a garbage truck body is not built like a regular steel container. The interior surfaces are coated in specialized anti-corrosion linings. The floor channels are designed to direct leachate toward drainage points fitted with heavy-duty seals rated to handle everything from battery acid to highly concentrated organic compounds. At the transfer station, leachate is collected separately, treated as industrial wastewater, and processed before it ever touches the ground. The truck driving through your neighborhood this morning is not just carrying garbage. It is carrying a slow chemical reaction that its engineers had to design around from day one. And while that reaction is building inside the drum, the driver is watching it. Not with their eyes, with cameras. Modern garbage trucks are equipped with internal monitoring systems that most people have no idea exist. Wide-angle cameras positioned inside the compaction chamber give the operator a live view of what the packer blade is processing with every cycle. This matters more than it might sound. Lithium-ion batteries are one of the most dangerous things that routinely end up in residential garbage. A laptop, a power tool battery, a vape device, crushed under 80,000 pounds of force, can go into thermal runaway in seconds, inside a sealed metal drum with no ventilation. That is a serious fire risk. Pressurized aerosol cans are another, a compressed gas cylinder, a propane torch someone forgot in a garage drawer. These are not rare. They come through on almost every route. The camera feeds give the operator the ability to stop a cycle the moment something unusual shows up. The truck's control panel is also fitted with what the industry calls a deadman system, essentially an emergency cutoff that halts all hydraulic movement instantly if the operator loses contact with the controls or an unsafe condition is detected. On some newer fleet units, built-in suppression systems can flood the compaction chamber with suppressant foam without anyone having to open a hatch. The driver of a garbage truck is not just operating a vehicle. They are monitoring a pressurized, chemically active, mechanically violent environment from a cab in real time for 6 to 8 hours a day. The driver knows. Time to tip. The truck routes to the nearest transfer station or landfill. This is where the final mechanism most people have never seen takes over. At the tipping face, the truck backs into position. The driver activates the ejection system, a single, massive hydraulic ram running the full length of the truck body begins to extend. This is not the Packer blade. This is a completely separate system. A steel push wall, flush against the front of the drum, begins to move. Slowly, steadily, with enormous force, it travels the entire length of the drum toward the rear, pushing the entire compacted load, all 15 tons of it, out through the back of the truck in one single controlled ejection. It looks like the truck is emptying its stomach. The compacted waste slides out in a dense, layered mass. It holds its shape for a moment before the weight of it causes it to break apart on the tipping floor. What you see on the ground bears almost no resemblance to the loose bags and bins that were collected that morning. It is a compressed, stratified slab of material, geologically layered by pickup order, dense enough in places to require heavy equipment to break apart. The whole ejection takes less than 90 seconds. And the truck that just did all of that is one of the simple machines in the fleet. While the residential rear loader handles bags and bins, a completely different animal is working the commercial routes across town. The front loader. A truck with a set of massive steel forks on its nose that hook under a commercial dumpster, lift it straight up and over the top of the cab, and tip it into a hopper above the driver's head. Some of those dumpsters weigh 4,000 pounds before the truck even touches them. Then, there are split body trucks, running recycling routes, with a divided drum that keeps glass, paper, and plastic physically separated during compaction, sorting in real time as the route runs, so that by the time the truck reaches the recycling facility, the materials are already pre-segregated. The compaction blade on a split body truck is essentially two machines operating in parallel inside one drum. And increasingly, on routes through dense urban corridors, electric garbage trucks are running the same cycle with no diesel engine at all. Hydraulics powered by a battery pack, no exhaust, quieter by a significant margin than anything that came before them. What happens to the compacted mass on the tipping floor is not the end of the story. It is the beginning of a different, larger one. At the transfer station, that waste gets consolidated with loads from dozens of other trucks and moved by rail or long-haul tractor trailer to its final destination. For most of it, that means a modern engineered landfill, a highly regulated structure with gas capture wells, clay and synthetic liners, and leachate collection systems that prevent anything from reaching the groundwater. But for an increasing portion of the world's waste, it doesn't go underground at all. Waste-to-energy facilities take compacted municipal solid waste and burn it at extremely high temperatures, using the heat to drive steam turbines and generate electricity. The ash residue, which is a fraction of the original volume, gets processed separately. Sweden has taken this further than almost any other country on Earth. Through a combination of recycling, composting, and waste-to-energy incineration, Sweden converts over 99% of its household waste into reusable materials or electricity. The country now imports waste from neighboring nations to keep its facilities running at capacity. That is what the destination of one garbage truck's load looks like when an entire national infrastructure is built around it. The truck that left your street at 6 in the morning, the one you barely glanced at over your coffee, is the first link in a chain that ends at a power grid, a recycling facility, or an engineered containment system built to last 300 years. The engineering doesn't start at the landfill, it starts at your curb. If that changes how you see the truck idling at the end of your block, wait until you see what a modern landfill actually looks like from the inside. The gas wells, the liner systems, the controlled decomposition. It is one of the most underrated feats of civil engineering on the planet, hiding in plain sight under a grass-covered hill. Subscribe so you